Hello ARRL members and QST readers worldwide. My name is Dave Kassler, KE0OG, and I write the Ask Dave column for QST. In the November issue, we talked a little bit about how to deal with an older tube amplifier and mating that to a newer rig. We discovered that there are two issues. One, that the usual modern radio is not capable of pulling to ground that many milliamps, whereas sometimes the relays that go to transmit in the tube type antennas want to send quite a bit of current. So the column shows where to put a relay. But there's the other issue that we didn't really address, and that's the automatic level control. What the ALC does is if the amplifier decides it's getting too much input, it will send out a voltage ranging from 0 to, of all things, minus 16 volts. And what that will do is it's intended to cause the transmitter to back off a little bit so it's not getting overdriven. Now, the problem is that a lot of modern radios only work with an ALC voltage of up to minus 4 volts. So we're going to take a look at a way that we can go directly from that to that with a minimum of interface. One way to be would be design some sort of an op-amp circuit that did thus and such, but a reader wrote in with a possibly much simpler way, and I'm going to show you that right now. Okay, here's the amplifier, like an old Heath amplifier or something like that, and you send the RF in. You also have got a connection right here that you send over here on the back of your, it calls it an exciter. Anything that drives an amp is called an exciter. We normally refer to them as our radios. There will be an RF out. This is the normal RF out. Okay, goes into here. An odd thing about amplifier circuits for power amplifiers is that they require not just a voltage from the driver, but also a fair amount of power too. So that's why it can take anywhere from 60 to 100 watts out to drive this thing. Now there's also, from the amplifier back and forth between them, if you ground this, this will cause the amplifier to go into transmit, as we discussed in the article. But another problem is that this thing sends a signal back here called the ALC for automatic level control. And it's a 0 down to a minus 16 volt signal. Whereas most modern radios are looking anywhere from 0 to minus 4. And if you drive it too much, it is possible to burn out the transistor here. So you don't want to connect that directly, even though they're both labeled ALC. So one thing that you can do, and I'll show this in a way that was recommended by the reader, we'll take this output right here, and instead of running it directly to there, we will put a series of 4 1K resistors. We will ground this, okay? Now this can be 0, in which case it's still 0 here. If this is taken to minus 16, okay, and then that would mean this is minus 12, this is minus 8, and this will be minus 4 right there. And then we take that and feed that in over there. So notice this is a voltage divider circuit. It actually does need to be grounded, okay? So when this is pulled down to minus 16 volts, you get 4 volts, 8 volts, 10 volts. You can use, I think, 1K resistors for this. This right here is a 0 impedance input. I should say infinite impedance. It will operate off of that based on the voltage, not on the current, okay? So this is a way that you can find minus 4 volts. Now you'll want to check this with your amplifier. Go ahead and take the 4, I say 4 in series, because 1K is a standard resistor value. And you've got 1K, 2K, 3K, 4K. So the voltage Generated across here is -4. So there's a very simple way that you can get 4 volts out, or -4 volts out of -16 volts. Now check that with an ohm meter, that when you touch that to ground, the 4 1K resistors to ground, check the voltages in between, make sure they are -4, -8, -12, and then -16. And then you can just send that 4 volts over there. Now that voltage, negative voltage, will vary. 4 volts on the ALC on an exciter, a radio, will actually shut the power all the way off. The 16 is what it takes the old radios to shut the power all the way off. So your voltage will be somewhere in between there. So I hope that's helpful and a nice little addition to this. And I really appreciate the reader who wrote in and suggested this. And until we next meet, 73.